And now we are finally the last topic that we want to touch, at least for this first cycle of lesson. And the topic is quite important, probably one of the most promising issue in the discussion about artificial intelligence in general. And of course, this is also useful for artificial intelligence in the area of architecture and urban planning. We are talking about the neural network. And of course, due to the complexity of this topic, we have to touch the neural network only in general, only in its key meaning and how to use. And what is the meaning of the neural network and when it is necessary to use. First of all, neural networks are algorithms. So it's not a fantasy, it is not a science fiction, nothing really extremely complex. Simply algorithms. And the most important element to understand the neural network, it is the similarity with the human brain. So basically, the engineer, the IT guys, create the neural network imitating the human brain structures. And this is a typical approach of Bionic, because as I mentioned to you many times, Bionic intend to take inspiration from the natural process without imitating the form. So the engineer, in the computer science field, the people study how the human brain works, the process, not the form, not the structures, but the process, and try to imitate inside their field. And it works really very well. It works well because we have to remember we are discussing the artificial intelligence. So if we need to discuss intelligence, then necessarily we have to imitate what it is for us, a human being, the most intelligent stuff in the universe, which is our brain. How selfish we are, by the way. The neural network, it is extremely useful in many fields. They are very performative in several disciplines. First of all, what it is very important in the neural network, it is neural network have to absorb data from something else. So the neural network itself, it is something which has no relationship with the rest of the universe. They need data. And the data, it is generated by sensors. Camera, CCTV, every form of sensor that you can imagine. For temperature, for wind, for everything. Every time you are in front of a sensor, include your watch, include your telephone, include the camera that you find in airport and so on, that one are somehow the extension of the neural network. The camera, your watch, your telephone, it is basically a stupid toy. There is no brain on the back of those elements. They are simply sensors. Something like sensors are your eyes, your touch, and so on. Finally, all those stimulation reach your brain, and your brain elaborate and have some understanding of the real world. It is exactly the same for the neural network. Neural network simply give sense, interpret the data which come from the sensors. Again, what it is very interesting in the neural network is their incredible ability to recognize patterns. What does it mean, patterns? Patterns is an English word which it means organization. For example, you can imagine a pattern of a fabric or a pattern inside a picture, a pattern inside a picture, or for example a texture on a wall made by different bricks or made by decoration. Pattern, it is a sort of form which has a regularity, which has a sort of meaning. So somehow the sensor generate raw material, raw data, which sometimes make no sense at all, just simply numbers or again patterns. And then finally the computer has an immense number of material, which again there are raw material, it makes no sense. And then how to use those data. Something like if you are in front of one new word, for example, you visit for the first time one country, and the people start to talk to you in their own native language, and maybe you are not fluent on that language. So your brain get data, get sound, eventually even get script, for example, in a very exotic language, which you never heard in your life, some strange dialect. You can imagine if the population of your country, your own country, start talking a very strict dialect, very remote, very unusual. You get data, but you simply don't know how to interpret because your brain doesn't recognize the pattern, doesn't recognize the meaning. Those are raw material. Then, with a small dictionary, you start to recognize sound, words, and you start to understand the meaning. The neural network, it works exactly in this way. It needs a sort of structures, a sort of process in order to recognize raw material. This is extremely important to understand the general components, the general meaning of neural network. So, the real world, what we call in our class the world outside the window, generate things. It is made by a certain kind of situation. For example, temperature, wind, movement of the people inside one square, the sound of the street, and so on. And those elements has no meaning. It starts to have a meaning when a human being recognizes a certain kind of pattern. For example, if there are a lot of people in the street, the human being say, well, something interesting or something dangerous, something unusual happened. Or maybe if you heard a big scream in the road, something dangerous it may happen. Because your brain recognizes into that noise a certain kind of pattern, which your brain recognizes as danger, or something good, or something bad, and so on. You can imagine, for example, a sensor, a radio telescope, which give in front of your computer a series of numbers. For me, it makes no sense because I'm not a scientist, I'm not an astrophysics. But maybe for a very experienced person who works in this field, that numbers means a great discovery. Maybe we discover another planet or another form of life in another world. Very fine. Or maybe it is simply a sign of an explosion of a supernova. Who knows? Only the expert recognize the pattern inside the numbers. At the same time, when, for example, you are coding a software, for you and for me, that kind of coding make no sense because we are not IT guy. But for an engineer, that coding has a very precise meaning. That kind of pattern, it makes sense. Neural network, it is extremely able to recognize numerical pattern, for example, a numerical sequence. It is very good to recognize, for example, image, sound, text, translation. So every time you are in front of a huge amount of data that we human beings are too slow to recognize, the neural network can generate an excellent word. I give you a very simple example, the translation. You can imagine that you are fluent in two languages. For example, in my case, I can recognize very well a local dialect in Italy, which is called Napoletano, which is a local dialect in the city of Napoli, and I am fluent in Italian. So somehow I can translate in between the dialect of Napoli into Italian. Maybe in your case, you are very experienced in English and French, or you are very fluent in Chinese and Italian, or in Urdu and Hindu. It doesn't matter. If you are in front of a text, for example, in French, and you have to translate into English, you spend a certain amount of time. For example, for every page, you spend half an hour. The same work, it can be done by computer maybe in just 1 second. Of course, the translation is not so good like yours because the computer, it uses some statistical process in terms of translate, but finally the work is much faster. Or I give you another example, even more simple, even more common nowadays. The neural network work very well in the recognition of face. When you are in airport and you have to pass the passport control, passport check, then you have in front of you a policeman who check your passport, look your face, look the passport and try to recognize with his ability if your passport is original or not. The picture in the passport have to be identical to your face. If not, problem come. The same work can be done in less than 1 second by a computer, thanks of the neural network. So you can imagine how many million of faces every day pass in a very big airport. Human being can't recognize possible danger, can't recognize every single face, but the computer can do in a very quick, in a very good way. In short, the neural network is very useful to cluster and classify data. For example, this is a simple list. They can detect faces, identify people in image, recognize facial expression. They can identify object in image, recognize gesture in video, detect voice, identify speakers, transcribe speech on text, recognize sentiment, feeling means in voice, classify text as spam. Every time you are in front of a massive quantity of data, the neural network can help you in all those fields. For example, when you use the software for transcription of speech into text, that it uses neural network, because your voice generate wave of sound. The wave of sound are transformed into binary code from your telephone, and the software recognize binary code, similarities into binary code. There are some software in your telephone probably which can recognize the music. You heard a music, you don't remember which music is it, you open the software and in few seconds the software recognize which music and eventually even which performer is singing the music or play the music. How to do? Because the computer has a memory? No way, the software is very small. What they do is to recognize the patterns of the music and then check over internet thousands and millions of music already stored into the cloud, into internet, and finally recognize which one is more adherent to what it is processing in front of you. So it recognizes pattern, mathematical pattern, of course. Neural network has the great capacity to recognize and classify, both recognize and classify patterns, but this process is not neutral. The neural network, exactly because they are neural, they are like a baby. You need to teach to a baby how to recognize meaning. For example, the baby must recognize the language. The baby must learn language and then recognize meaning. The baby must learn what is danger in order to recognize the same danger in the future. The child must learn the behavior, so in the future they can act properly in front of a certain situation. This is why we have school and we have university. So the neural network in every possible field, image recognition, recognition of pattern, voice recognition, they always must have a training. And this is the most fascinating stuff inside the neural network. The neural network is created to learn. And a very interesting issue is the neural network work very, very well. They are much better than any human being in recognize pattern. But the problem is to transform those natural situation, real physical situation, into data. But this is not very difficult because, for example, the digital picture did exactly this job. So they transform a three-dimensional world into two-dimensional and then generate a sort of grid. And every single pixel has data. So the three-dimensional world, it is transformed in a series of pixels. Every pixel has a certain kind of number and then the game is done. The digital camera transforms the real world into numbers. The voice is even more simple. When I speak, in front of me there is one telephone. The telephone takes the waves of my sound, of my voice, into numbers, and then it is done. Simply, my physical voice, it is transformed into binary code. That is very simple. It is already done many, many years ago. What it is very interesting in our case is the neural network. It is very diffuse in the urban study and also in architecture. For example, cellular automata, it is used inside the neural network. Or better, there is a very interesting software which put together cellular automata and neural network. This slide mentions very clear that a cellular automata model using neural network to simulate potential or alternative urban development patterns based on different planning objectives. So there are a lot of possible applications of neural network inside the field of architecture. Now it is necessary to propose one definition. Finally, what is a neural network? According with Maureen Caudill, a neural network is a computing system made up of a number of simple, highly interconnected processing elements, which process information by their dynamic state in response to external inputs. The artificial neural networks, ANN, it is a mathematical simulation of our brain, of our cerebral cortex. But it is, of course, much smaller, because generally speaking, the artificial neural network maybe have 100 or 1000 processors units, but our brain has billions. So, generally talking, the neural network of the human being it is much more complex, and the computer is still extremely simple compared with our brain. But the interesting element is the speed of calculation. The computer is much faster than us. What it is very important in the neural network, it is try to understand how they are organized. And they are organized in layers. We read it together. Layers are made up of a number of interconnected nodes which contain an activation function. Patterns are present to the network via the input layer. So it is one initial state, which communicates to one or more hidden layer, where the actual processing is done via a system of weighted connection. Now, this explanation, ladies and gentlemen, it is very complicated. Actually, the process it is much more simple. Also because it is simply hidden. They are software, they are processes which are already created. You no need to have any form of headache. It is done by somebody who know nothing about architecture, know nothing about urban planning. They have no experience in face recognition, security, police, and so on. They are engineers and they are great guys who simply generate this simple process and then give to us. Our task is only to understand how it works in general and then simply apply. What it is very important in our discussion is these pictures. This picture it is how the neural network are structured. If you check the picture on the bottom right, you have the input layer on the bottom, the hidden layer in the middle, and the output layer above. Now, wait a moment, we are architects, don't get crazy about this kind of stuff. You simply need to remember that you have one door which put the data inside one strange environment, which is the hidden layer. Then inside this strange room, something happened, shake the box, numbers start to run around, and then finally you have a result. This one is very clear and very simple to understand. You have input, black box, output. 3 different layers. This is the only meaning of the sentence that we have mentioned before. We have layers. We have different universe, different rooms. One entrance, a processing room, one exit. That's it. You throw inside raw data, something happening between, and then output data. Something like when you must have a surgery. You go inside the surgery room, input layer, then you fall asleep, the doctor operate, you don't know what happened, and after, when you go out from the hospital, you are perfectly healed. You are happy and you have a long life. That is the case. So different layers. What happened inside the surgery room, it is not your business. It is only the business of the doctor. It is only the business of the process of calculation. And that's it. For you, those information are enough. A more complex diagram, if you want to understand more about this kind of layers, it is the picture on the left side. Again, you have layers, which is a kind of rooms. You have the input, you have the weight, you have the net input function, you have the activate function, and then the output. At the same time, we have to touch a very important topic always related in the neural network, which is the deep learning. Yes, because the neural network, finally, it means deep learning. It means the machine can learn from the data. Example, take a very old calculator. If you remember, people of my generation remember that in the past, the calculator made operation 1 + 1 = 2. Fine. But there is one function which is memory. In that calculator, which was actually very advanced at the time, you have one function which permits to you to memorize one number. This function memory, it is a sort of storage, exactly like your computer nowadays. In your computer you have the hard disk. What is the hard disk? Hard disk, it is a stupid big box where you put your picture, data, document, and so on. Then the interface take those numbers and transform into sound, into visual, picture, movie, or DOC document, or whenever. So the hard disk, it is simply a stupid box. There are only binary code, 01010101, and so on. That's it. There is nothing more. Then there are other software which transform those rough data into one picture, for example, of your dog. Then this is not intelligence, this is a storage. The intelligence is when the machine, without your help, can recognize one element. For example, if you ask to your computer, "Dear computer, please open the movie of Charlie Chaplin," a human being can understand that Charlie Chaplin is a very famous actor. Then he search inside a storage one movie, one DVD, one film of Charlie Chaplin, and then display on the screen. But the computer can't do, at least not now. The computer is not able to understand what is Charlie Chaplin and then find the right movie over internet or inside your computer, in the hard disk. Software like Siri of Apple, for example, in that case it is a little bit more smart because it can recognize meaning from your words. And that is called, in fact, artificial intelligence. So the key point of artificial intelligence is learning. For example, I say Charlie Chaplin. Charlie Chaplin is not only a sound. On the back of that sound, it has the meaning of one name, and that name corresponds to a very famous movie star. Then the computer must learn what does it means, the sound Charlie Chaplin, give to that sound a meaning, that sound corresponds a name, that name is an actor, that actor made certain kind of movie, and then the computer or the artificial intelligence can pick up one movie in between many of that specific actor. But above everything, there is learning. This is why it is called deep learning. In order to be a little bit more technical, the deep learning, it is composed by several layers, and we already mentioned this case. For example, input layer, hidden layer, output layer. They are sort of universe, sort of rooms. The layers are made by nodes, and this is a very important topic. A node, it is just a place where the computation happens. They imitate somehow the neuron of the human brain. They are actually very different, but just to give a sort of metaphor, nothing more than a metaphor. A node combines input from the data which come from the external world. Then those data, it cannot be used directly. This is the big difference inside the neural network, because those input, finally, we must understand one key question. Are those data x1, x2, xm important? And how important they are. For example, in your daily life, you have some tasks to do. Some are very important, very urgent, and some is really not important. You can delay as much as you want, or you can give a relative weight. This second point, the issue of giving weight to the input data, it is the trick of the neural network. as this slide mentioned, these input weight products are summed, and then the sum is passed through a node, so-called activation function, to determine whether and to what extent that signal should progress further through the network to affect the ultimate outcome. It means, finally, that the calculation of weight give the importance to the input. For example, in front of you, you have thousands of data, thousands of stimulation. For example, some stimulation are very important. Your room, it is too hot, or you are in front of a very clear danger. So that information, it's very important, so you give a very important weight. Some people give a lot of weight, a lot of importance to the family. Some other people give a lot of importance, a lot of weight to the career. Weights are the relative importance of a certain kind of input or data, as you want to call, in a certain environment. The key element, the key important point is how to give weight to the inputs, and that is the trick of neural network. Only when the calculation of the weights it is generated, it is created, then the neuron, in this case the artificial neuron, the node, can be activated, and then it can work. This is the very important point in all this system. In my personal point of view, for our specific task of artificial intelligence in the world of architecture and urban planning, to understand the system of weights, it is not really very important. But it is more important to understand the logic. So, the inputs are raw material. Some material is important, some material are not important. Something like if you must extract gold or diamond from a rock, you have the diamond, which is a very important element, and the rocks, which is simply dust you must throw away. Every engineer, every expert can understand the difference in between rock and diamond. This is the logic of giving weight. The human being know exactly that the diamond have some value and the rock has no value at all. At the same level, in the neural artificial network, the input in front of the computer, they have no value at all. So the weights is the way to give importance to different data. So I give you an example. One camera acquire image second by second, instant by instant. Sometimes there are no faces in front of the camera, but only one chair, one plant, and so on. In other cases, there are faces in front of the camera. In other cases, there are terrorists in front of the camera. So the weights say if the image looks like a plant, a chair, or a floor, the inputs, the weight, it is basically zero, nothing important, it is not a face. If the camera recognizes a face, it must have a weight. Then, if the pattern of the face, if the geometry of the face match with a given image of a terrorist, then that weight becomes extremely high, close to 1. Because we know that the weights start from 0 to 1. That is the logic. So, the weights, it is given according with some specific importance of that specific task. In this picture, we just look a little bit more closely what happened in this kind of strange hidden layer, and especially what is the issue of the weight. So first of all, the slide, it touches the process of learning. Yes, because in fact, learning we are talking about. The neural network can learn. So there is a very good movie in internet. On the bottom, you can find the website, and in this case what it is very important to understand is the initial layer, it showed the input data. Then it exists a sort of weighting process, which it means the process generate random weight. Then it starts a series of cycles, and those cycles go and back, go and back, go and back, start to understand how far is the answer from the truth. This is extremely important. One example, which is very common in the algorithm made by the search engine in internet. For example, you have to recognize one color. You search one color. Then several colors are proposed. Then the point is, how far is the given color, the input layer, from the color that I find in the storage? Is it close? Is it far? And then those weights are adjusted into different cycles, it is also called epoch, in a way that finally that kind of color, it is recognized into the final output. So at the beginning it exists some random guess. So the stupid system choose 1,000 colors, choose 1,000 of pictures, and then finally it adjusts and progressively close the selection of images, the selection of random guess into a few cases. That few cases have a higher probability to become closer to the final goal of the research. This is how the neural network works. Then for you, those information are much enough to start your understanding of the neural network system into architecture and urban planning. This slide is quite complex because it is a purely mathematical problem, but at least we can extract 2 or 3 meanings which for us are extremely important. So first at all, one idea that we can extract from this complex information, from this complex topic, is this. Every search of neural network, every process of deep learning, every possible solution cannot be known a priori, which it means at the beginning we don't know what the hell is going on, which one is the final solution, because we are in front of such kind of great complexity that we have no idea what is the final solution. So one idea which is very important to extract from the first sentence is that every possible analysis based on a neural network requires a large number of individual runs. And this is not a problem for computer, because the computer is extremely fast in this kind of process. So the best solution, it comes from different cycles, different, we can call generation, ages, era, as you want to say, which calculate and optimize the search. That is very, very important. The second element, which is key point in our discussion, is that the neural network have to be trained in order to have deep learning. What is deep learning? It's a process which train the artificial intelligence system. Now, the interesting point is that this kind of analytical tool, it is not valid only for one specific task, but it is able to be used in every possible task. So this kind of system, and this is also valid for the genetic algorithm, you don't have 1,000 of genetic algorithms, you don't have 1,000 of training network, neural network. It is only one. It is the same. It is good for everything. This is the great power of this system. Once the system it is optimized, it can be used for many possible search. The third key element that we can extract from this image, this slide, is on the bottom. The global minimum is that theoretical solution with the lowest possible error. This is very important. If you check the image, it is a sphere. Now, the bottom of the sphere, it is the point where the optimal solution it is generated. But, as I mentioned before, it may exist some local maximum, which is not the absolute maximum. So it is very important in the neural network to have a sort of smartness, you can call, in order to distinguish the local maximum with the global maximum. And this is why you must have very often parallel process of calculation, something like in a large scenario, in a war, where the single battle are coordinated together. So it is not important who win the local fighting. What it is more important is who win the war. So the local maximum is not very important, or at least it may be important in a certain kind of condition, but what it is very important is the global maximum. And this picture is very important to exemplify what we mean. This slide is quite simple because it simply says what is the application of the neural network. First of all, the neural network can be basically used for everything, and this is a very interesting point. For example, capturing association or discovering regularities within a set of patterns, which it means recognize patterns, which could be a face, which could be a color, which could be, for example, the image of a dog. You can imagine in internet there are a billion pictures of dog or cats or flowers and whatever. So if your keywords say dog and red, the search engine using the neural network search everything which is red, for example a tomato, but the tomato, it doesn't look like a dog. So they must put together dog and red in order to generate the searching of a red dog. That is how it works. Point number 2, where the volume, number or variable or diversity of the data is very great. For example, if you have a huge amount of numbers from sensors, then those huge number of data is meaningless for human beings. So this is why the machine can perform much better in recognition of patterns. Point number 3, the relationship between variables are vaguely understood. Point number 4, the relationships are difficult to describe adequately with a conventional approach. These are 4 points where the neural network works very well. So it seems that the neural network is very good. It is the paradise. We find the solution for everything. But unfortunately, the paradise, it doesn't exist in this world. There are limitations. One very famous limitation, it is called backpropagational. And what does it mean? It means that the process of weighting the hidden layer inside the neural network that we described before, it is quite controversial because it is really like a black box, as we described before. We have data which come inside, then there is the black box, the hidden layer, which is called hidden exactly because we cannot understand what happened inside, and finally we have the output data. The black box, the black propagational neural network, is the problem because the user, the human being, has no way, has no role to understand what happened inside the black box. Mistakes, correct process, some devil who play cards, we have no idea. And this is a little bit controversial because the most of the process of our daily life nowadays, it is based on computer, and it is based exactly on this neural network. This is critical, not only because the final result could be wrong, because in most of the cases the final result is correct. The problem is different. The problem is if you have the output, how to understand where the output comes from. This is extremely difficult. Something like you get $1, but you are not able to understand if this money is honest or it comes from crime. You have no way to understand where this incoming comes from. And this is a problem. If you say, I don't care because I simply want that money, that is fine. But if you are a person with high honesty, if you are a person with high integrity, you must understand if that money are honest or not honest. Because maybe it is earned by crimes and you don't want to be involved in that crime. To have an example which is much more concrete, when you have an output or simply one email from your mailbox, you won't understand if that email is correct or wrong. It is harassment, it is spam, it is a real person, it is a robot. Well, there is no way to understand where those emails come from. Touch the topic of the deep web. That is exactly a very concrete example. The deep web contains everything, include very useful data, but unfortunately it contains a lot of crime. So it is very difficult to understand if a certain information are correct or incorrect, because the deep web, it is simply untouchable. You will never ever understand where those information come from. And that is the problem of the backpropagational neural network. The black box, this kind of hidden layer, work in a process that no human being is able to understand. In my opinion, this is a very critical problem. So this slide also mentions a very important sentence in the culture of internet. With the backpropagation, you almost don't know what you are doing. And this is completely correct. For example, if you are doing a mathematical calculation in your brain, you know what you are doing because your brain controls the calculation. When the calculation it is made by an electronic calculator, you don't have the control of the calculation. At most, you can recognize if the calculation is correct or incorrect. But when you are dealing with the neural network, you can imagine that you have in front of you a calculator of immense complexity. All the calculation that this black box, this strange machine, strange organism is doing, it's very important for your life. So the question is, do you want to give your life and eventually the destiny of all the humanity to a black box which you cannot control? Because, this is very important, the machine learning, the neural network, think by its own. It is not controlled by you. It is not simply a leverage that you can control, open, close. That's it. You can't control because the learning and especially the strong artificial intelligence can be different from yours and you will never understand. Something like you will never understand what is the thinking of a person in front of you. The head of that person is a black box. You will never understand what is the process unless you start to decode their action or unless that person is telling you what he's doing. And then the question is he telling the truth or not? Well, the machine cannot tell you the truth because the calculation inherent inside this black box, it is too complicated. We read together. The final product of this activity is a trained network that provides no equation or coefficient defining a relationship behind its own internal mathematics. The network is the final equation of the relationship, which it means there is no equation, there is no formalism, there is no paper, script, clear definition of what the network really is. The network exists by its own. Another weakness of the neural network is that the black propagation network tend to be slower to train than other types of networks. This is limited to the back propagation networks, of course. There are other systems which is much better. But the problem is sometimes those kind of calculations are very time and energy consuming. And this is a problem for very complex process of calculation. But then, in order to be honest, we also must mention some advantages which is very clear in the neural network. I list 3 points. Depending on the nature of the application and the strength of the internal data patterns, you can generally expect a network to train quite well. This applies to problems where the relationship may be quite dynamic or non-linear. It means simply that the neural network works very well. So it is proved that the neural network gives good results. So nice, it works. We don't know how it works, but it works well. Point number 2, the artificial neural networks provide an analytic alternative to conventional techniques, which are often limited by strict assumption of normality, linearity, variable independence. Point number 3, because an artificial neural network can capture many kinds of relationships, it is allowed the user to quickly and relatively easily model phenomena, which otherwise may have been very difficult or impossible to explain otherwise. Which it means the artificial neural network give a quick and easy relationship in between factors. Then the human being can use very easily. Now it is necessary to illustrate one possible example which is descriptive of the process of neural network inside the discussion of urban analysis and even urban planning. So we said that the neural network work in terms of generated weights. It works first at all to generate different layers and then create nodes. Finally, we give weights to these nodes and then output come. So in this case, the generation of optimal weights, it comes from a set of training data. This is a key concept. It is very interesting because the author of this paper intentionally used the words training data. Yes, training, because in fact every neural network, it is based on learning process. This is why it is also called machine learning. Now, the sensors inside the street, inside the city, and the GIS data are, generally speaking, the sources of data that finally will become fundamental in every possible neural network training and also neural network weighting. Here we must touch a very important point. We have data from sensors, we have this kind of software which is the neural network, and then we fill the neural network with the data. What it is very important to understand in the description of the artificial intelligence and urban planning in this case, it is that for human beings it is extremely difficult to generate relationship in between data. Yes, because they are too many, too complex, they are just numbers, and so it is very hard to precisely understand what the data means. So this is why the machine learning, and in detail the neural network, it's very useful to create a relationship in between site attributes and urban development. What does it mean, this sentence? This sentence simply means that you have data from the sensors, you throw inside the black box the neural network system, and then the machine starts to analyze and to generate correspondence. Yes, because this is what the neural network generates. Relationship. The neural network creates an understanding of the data, what the data means. So this is why it generates a relationship between data. In this case, it is called site attributes, but site attribute, it means simply data, weather, traffic jam, noise, whatever data you want to consider. And then link those data with urban development. Actually, urban development is just one case, because urban development, the word urban development, simply means development of a city, what comes next in that specific urban situation. But actually, the neural network can be used for example, analyze the past of a city, or analyze the dynamic, and yes, of course, also understand what the city, the future city, will be. Now, there are two way, as the slide mentioned, to use the empirical data. The first one, it is the data can be directly used to generate realistic simulation, which assumes that urban growth proceeds according to the historical trend. And it means that the data could be indicative, could be descriptive of the situation, the real state of the city. So somehow, for example, the data can be trustable to understand what the city is in this moment. This is not normal, this is not automatic. We have to be very clear on this point, because in general there is no, in the history at least, there is no direct connection in between numbers and reality. The correspondence in between data, numbers, and reality, it becomes something very modern. For example, in the Renaissance or in the Gothic age, which it means one period of time which stands for 1,000 years, there is no direct connection between the reality and numbers. Some Greek mathematics, and then finally Fibonacci, indicate that the numbers and the geometry could be indicative of the reality. But it is not normal. Only in the modern time, in the contemporary age, the data become really indicative of the reality. Attention, many physicists, many mathematicians, many people who belongs to the hard science can say that is normal, that is very correct, and I have to add nowadays that interpretation is correct. In the past, and probably in the future, there is something else to be more adherent to the reality. Anyway, don't want to make philosophy today, but the point is data, numbers, it is indicative, it is descriptive of the reality of the city. This is what the first element means. And also could be useful to indicate the growth, the development of the city, both in the history but also in the future trend of the city. The second point is the original data can also be modified according with some criteria. This point, it is very interesting in my personal opinion, because what happened in the urban planning and urban design, and in general also in the architecture? It happened that you have a certain kind of situation, and part of the study, it is the description of this situation without put any form of intervention. You are simply like a photographer who go into a specific site and take a picture of the reality without any personal opinion, without putting your own idea, your own interpretation of the reality. You can imagine, if you want to have a metaphor, the difference in between a painter and a photographer. I know very well that the photography, it is not neutral. Somehow the picture represents the idea of the photographer. This is very clear in my opinion. There is a very beautiful movie made by Wim Wenders, the famous German director, which is called Lisbon Story. And this is a very interesting speculation, artistic interpretation of the objectiveness of the, in this case, a filmmaker. But anyway, again, no philosophy today. The interesting point is the photographer, generally speaking, represent the reality as it is in front of the lens. In this case, the data may represent only the state of the art, the situation of the city in a specific moment. For example, when we did the interpretation of the Longshan Temple in Anhai, we only register how the people use the space without put our opinion, our consideration. It is also true that every time you study a specific situation in the city, the people did not behave normally. So there is a slight difference in between the complete free use of the space of the people and when you put sensors or you analyze the behavior of the people inside the space, inside the city. But anyway, don't make too complicated. Today it is just an introduction of the study. So what we want to say that, generally talking, data represent the situation of the city in a specific moment. But in the case of urban planning, or in the case of design of architecture, the architect somehow put his own intention inside the city, which it means that the architect, the urban planner, register the reality of the city or the architecture or the parcel or the building site and say that it is possible to register some problems and some possible intervention which solve local problems. I want to express again this idea. The city has problems which have to be solved. And then the architect or the planner give his own interpretation how to intervene on a certain specific area. So, this is the second point, the original data can also be modified according with some criteria, which are related to the planning objectives. That is the point. So the data that we insert inside the machine could be what it is registered by sensor, but also can be modified according with the intention of the planning. Now, in this case, we want to describe some idea which is related on the previous issue. So, when you have the neural network, which basically means you have data from sensors, then finally those data have to be thrown into the neural network, which is representing these complex figures on the right side of this slide. Now, we also said that there is the possibility to generate modified data. Modified data, it means the architect, the planner, insert in the machine modified training data. Attention, modified training data, it doesn't mean only modified data, but it means data, modified data, which is used to train the machine. Somehow the human being intentionally put some false data, some wrong data that doesn't correspond to the reality of the GIS database or the GIS analysis or sensor data in order to obtain, intentionally, I repeat again, alternative or ideal urban pattern. It means that the architect, the urban planner, with his own intelligence, understand that the reality has some problems. For example, the historical land use may have some weakness, may have some situation which is not ideal, has some radical problems. I give you a very simple example. The roads are too narrow, or the space are too big, or the roads are not at the human scale, or the land value has some problem. So those kind of data which are corrected by the human being, are modified by the human being, could be very useful to generate urban growth for the future. The picture on the right side of the slide, it is very interesting because it is divided in two main parts. The upper part, it is called training, and the lower part, it is called cellular automata simulation. On the upper part, you have two different kind of input data. On the left side, you have a GIS database, GIS analysis, which finally become the site attribute, climate condition, population, density, and so on. On the right side, you have the remote sensing, the original training data, the planning objective. That is the point. So on the left side, you have the objective situation from the real city. On the left side, you have remote sensing, which is still data from the real city, but you also have the planning objective. Now, the planning objective is the intention of the administration, the intention of the architect. So, the remote sensing, the original training data, plus the intention of the architect, the intention of the public administration, which consider the actual state of the city with some problem, together generated a modified training data set, which it means that, I repeat once again, you have the sensors in the city. The sensor in the city register the situation of the city in a certain moment. This situation may have some problem. The architect, the planner, the expert merge together the data of the city plus intention, plus vision, plus planning objective in order to generate modified training data set. Then all this stuff, it is put together inside the neural network, and you can also easily understand input layer, hidden layer, output layer. Then we have something very interesting. The training part of the system go down in this slide, and you have a cellular automata simulation. You have an initial stage, you have the input layer, hidden layer, then you have the output layer, and then development probability. This is a key element. You are not going to have the ultimate final perfect solution, but everything is statistical. Everything it is based on probability. Then you have the simulation of the urban growth. And then the question is this urban growth based on a neural network satisfying? Is good, or it has some radical problem? If there are some problem, then you must come back to the initial stage, do the simulation based on neural network again, and maybe again, and maybe again in different loop, maybe even 100 times, if time permit, and then finally you have an optimization, development probability, which is optimized better than the previous cycle. Or maybe you have in front of you alternative possibility. And then finally the human intelligence choose one which is more appropriate. Then final stage, and at the very end you have alternative growth of the city. Now the alternative growth can be one or many. And then finally you have a possible scenario for the future. This process is very important for our course. This slide mentions how the process of development evolve inside the neural network elaboration. Now, interesting point in this slide, in my opinion, is that every simulation of urban planning, it is based, like in cellular automata, into a grid. This grid, it contains the characteristic of the terrain, the characteristic of the city, and all the data that the sensor register from outside and include into the simulation. Now, as we mentioned, we have 3 layers: input layer, hidden layer, and output layer. But what it is very important and descriptive in this slide is that we are discussing about development probability of a specific area of the city. You can imagine that the city, it is divided into cells. Or better, the city, the real city, it is described, it is represented into cells. Every one of these cells represent, for example, a district or a parcel or a sector of the city. It doesn't matter. Every cell has data. So according with the neural network elaboration, every cell has a specific value and corresponding weight of development probability, which it means basically that what is the probability that a specific area, that specific parcel, that specific district may have in the future development. This kind of probability, it is based on input data, which means the data that the sensors or the planner input inside, the weight, and finally the intention of the administration. For example, architect, for example, the urban planner. In this case, the simulation at the end will generate probability of development according with the given data. In the last sentence, they say the simulation will continue until the total number of convert cell is equal to the required land consumption. And this one is a key element. If you remember the cellular automata process, which is a little bit more stupid than the neural network, the cellular automata evolve into a sort of balance. But this balance, it is generated by very simple rule. And in addition, every single cell doesn't have data. It is not a complex parameters. It has only two states, alive or died. In this case, you have a cell with a lot of very interesting and very complex data. So the neural network simulate and evolve until a certain kind of situation, balance, it is reached. For example, in this case, land consumption, but you can have many other possible parameters which have to be satisfied in order to get a certain kind of balance and cycle. What I mean is the neural network will generate a different cycle, different generation until a certain kind of balance is reached. But on the contrary of cellular automata, in this case, the neural network stopped when complex factors are reached. In this slide and in the few next, we point out some important concepts that at this moment it is necessary to discuss in order to understand deeply the process of neural network that we described in the previous case. First of all, it is clustering and grouping. Clustering and grouping simply means generation of cluster, group similar element. We have to remember that the neural network, it is very able to detect similarities. I give you many times the same example. A neural network, it is very good to face recognition. Why? Because you have a database of picture which is collected by police time to time, for example, your passport, your ID card, and so on. Then, thanks of this database, when a CCTV camera records your face, automatically the neural network can compare your face with a million or billion of faces and understand if your nose, your eyes, your mouth correspond to a given picture. So this is the idea of clustering and grouping. Now, inside the urban planning and urban design, and in general in every process which concern a large number of data, this clustering and grouping is very important because the machine can learn that similar data have to be put together. And this is very important, for example, in order to recognize a pattern. And in the urban planning, it is very able to recognize, for example, human behavior pattern in the use of the city, or, for example, recognition of typology, morphology pattern inside the city. So, in the urban study, clustering and grouping of morphology and typological data inside the city can be fundamental in the machine learning in the urban analysis. This is one possible example. There are two cases that Nicholson in his discussion proposed. Number one, it is search. Number two, anomaly detection. Searching, it means comparing documents, image or sound to surface similar items. And this is clear. It is, for example, face recognition, sound recognition, music recognition, and so on. But it is also very interesting, in our case, in the case of urban design, in order to search similar pattern of human behavior. Similar pattern, for example, in the case of how the people use the city, which is the most successful structures of a city or a building, what is the right sequence in order to perform better in a building design. This is some case. The second case is even more interesting because it concerns anomaly detection. Anomaly detection, it is, for example, differences. In this case, it is mentioned fraud. But what happens if this anomaly detection, it is related on earthquake or landslide or some anomalies in the terrain, road, or for example, in the recognition of the bridge safety, structure, building safety, and so on. So anomaly detection could be extremely useful if we use this kind of analysis in the safety for the building. Actually, there are already some company who is doing this job. For example, thanks of the satellite image, they recognize if a building shaking too much, if the modification of the stability of the building is inside the range or outside the safety range. Anomaly detection is a very important application in neural network area for the architecture and urban planning. This slide concerns the deep learning networks, which it means how the machine learns, how the machine is able to interact with the external world without the intervention of the human being. This case is quite classic. It is the recognition of the face, the recognition of the eyes, the recognition of the nose, and then finally put together the elements to recognize a face of a criminal or somebody else. Now, the interesting element, in my opinion, to join this kind of research with urban planning and architecture is the deep learning networks in the area of urban planning. For example, a software, a neural network can recognize a pattern inside the city without the intervention of the human being. Yes, because this kind of neural network, as it is mentioned in this slide, it is very good of discovering latent structures. What does it mean, latent structures? Latent structures, these structures, pattern, order system, which is not evident at the first sight. So, it is very important, for example, in the case of archaeology. The application in the archaeology is very good because the archaeology concerns the investigation of territory where in the past an ancient city exists, but now it is lost. But some sign, some structures are still there. So it is very important, in my personal opinion, to use the neural network and the ability of discovering latent structure in the cases where the structures are not evident anymore from the human being. This is a very interesting application. So not only understand the nose, the eyes of the face, which is good for security, but also in the area of urban study and archaeology, it is an extremely important element. Actually, the possibility of application are immense. For example, recognize some style of drawings in painting, in architecture drawings, where the author is not certain. This slide, it is interesting because it gives the possible use of the neural network. For example, hardware breakdown, health breakdown, customer churn, employee turnover. So the application in the neural network is to recognize some trend, some pattern, some situation, which is not very evident to the human being. But inside a certain kind of behavior, there are some signs, some data, some element which can be very helpful to predict future trend. In my personal opinion, this slide is very important and is very accurate, so I want to simply read with you and eventually give some little comments because it's very clear. Each node layer in a deep network learns features automatically by repeatedly trying to reconstruct the input from which it draws its samples, attempting to minimize the difference between the network's guesses and the probability distribution of the input data itself. Which it means that at the very beginning you have data which you input inside the neural network, and those data are not really very well organized. Sometimes they are very confusing. They are what it is called unstructured. So without structure, without order. At the very beginning, it doesn't matter if the data it is organized or not. But the deep network, it is made in order to generate cycles where the difference in between the probability at the beginning very low and the final certain output or the final correct output, it is progressively minimized. I won't repeat once again. You have some data. Those data very often doesn't have very good structures. They are confusing. They are without any specific order. So you put inside the neural network start the process of give weight, elaborate into the hidden layer, and then generate the output. Then the question is this output correct? Does it make any sense? At the first round, maybe not. So you repeat again and again and again and again. Finally, the final goal of the neural network is to minimize differences. At the beginning, there are probability. Those probability, it is called in this case guesses, imagination. Then this kind of guessing become progressively more and more close to a maximum. This kind of maximum should not be local maximum, but must be absolute maximum. This is why the neural network work in parallel in different area, in different section of the mathematical dimension. This kind of final output, the output layer, it is in most of the cases predictive. Predictive, it means that it is those data are able to guess the future. Those data are very good in order to generate possible solution. The best solution? No, there is no best solution in this kind of dynamic system. But there are solutions which is more appropriate by a certain kind of situation. So, as the scholar, the expert very often said, and we already mentioned in the past, you should remember that the neural network, it is born in ignorance, which it means he knows nothing. The neural network knows nothing. It is a kind of flat, no data, zero, no mind at all. So what it is very important is that at the very beginning the neural network just guess. The system is not scared of mistakes because the system, it learns from its mistakes. Mistakes are the basic element of neural network, and this one is a great lesson that we human beings have to take. Very often people are afraid of mistakes, are afraid of losing face. This is too proud. This is a big problem. We learn from mistakes since our childhood. Neural network is based exactly on this process. A neural network is a corrective feedback loop, rewarding weights that support its correct guesses and punishing weights that lead it to error. I won't mention again, the neural network process always generates mistakes, but at the same time it corrects the mistakes. How to do? The process giving weights. And exactly like the genetic algorithms which follow the biological process, the weights which are correct win. The guessing which has problems, which made mistakes, error, it is punished and then finally die. This slide become very descriptive about how the system, how the process of guessing and correction it work. It is quite easy to understand, so I don't want to give so much comments. Anyway, what it is very important to understand is that the neural network work in terms of loop. It generates data. Those data are compared with what it is called ground truth about data, and then repeat the calculation again in order to minimize the error. This is the key point that you must take from this picture. In this case, we are going to discuss very briefly the connection between a neural network and artificial intelligence. Here we touch a sort of, shall we say, a philosophical problem, because some scholars consider the neural network still a brute force. What is brute force? Brute force, it is a simply attempt. For example, if you have a password composed by a certain kind of number, you try every number, 1, 2, 3, 4, 5, and so on, until you find the correct combination. So it is called brute force because there is no intelligence. It is only stupid application of a simple principle. This is the definition of brute force. But in another case, the neural network, it is considered as a sort of intelligence, a sort of artificial intelligence. Because it is true that the neural network, it is still based on cycle, on process of repetition. But this process of repetition is extremely smart. It is something like a child which try to play games, start to play games, but this playing games, it is the beginning of his training for his future work, future war, future relationship with other human beings. So the neural network is brute force or it is a form of intelligence. I give my personal opinion. It is a real intelligence. It is a real artificial intelligence. Maybe it is simple. Maybe we human beings are more intelligent than the neural network, but this one, it is real intelligence in my personal opinion. What is very interesting, very intriguing for me is that this form of neural network, it may evolve in something different from the human intelligence, and that is very interesting, very tricky for our future. I want to conclude the course of artificial intelligence with one example proposed by Anthony Gar-Onye and others in a very interesting paper. It is an application where it is studied the simulation of the city of Dongguan in China, in Guangdong, the province of Guangdong, and this simulation, it is based on several parameters, which is illustrated in this slide. So distance to the major city, distance to the suburban area, distance to the nearest road, distance to the nearest expressway, distance to the nearest railway, neighborhood development level, agriculture suitability. So those elements are put into the neural network in order to understand which one is the possible development using weights. In the first slide, we find the development of Dongguan in between 1988 and 1993 using normal weights. In this city, it is the simulation as a monocentric development, which it is one possible development for the future of the city of Dongguan. In this case, it is simulated a possible development of the city of Dongguan using a strategy based on polycentric city. The weights in the previous slide and the weights in this slide, it has different calibration. In the first case, we have a monocentric city. In the second case, we have a polycentric city. This is a simulation where there are a special weight, special importance in the urban development with strict protection of agricultural land. This is very important because we all know that there is a very strong opposition in between urban development and agricultural land. Generally speaking, the big monocentric city, but also the polycentric city, they have a serious problem in the progressive occupation, progressive destruction of agricultural land, which is a big problem for food provisioning, water, environmental protection, pollution, and so on. If the designer, if the planner decide that we need to have a strong protection of agricultural land, which one is the possible development of the city of Dongguan or other city? This simulation using neural network create a possible scenario using those three possible parameters: monocentric city, polycentric city, protection of agricultural land. We can imagine the same process using different parameters, completely different, for example, land use, value, or economy, or density, or other elements, and then the simulation will give not the best solution, but the most possible scenario according with the given data. In this case, I won't give a very simple summarization of the idea concerning artificial intelligence. I want to express at least three key elements in artificial intelligence and urban planning and architecture. Point number one, parametric. In the parametric, human being input data and the software modify the architecture accordingly. In my opinion, this is not artificial intelligence. It is a complex calculation eventually, but there is no intelligence. My opinion only. Number two, generative architecture. The human being still have influence on parameters. Artificial intelligence can generate architecture based on parameters input by human, but with a sort of independency. In this case, we are touching a sort of intelligence, not very sophisticated, but quite interesting. The real artificial intelligence, it is where the machine generates architecture which can be unpredictable by human in any way. The combination of parameters are too complex for human being to be understood. So in this case, the real artificial intelligence can generate a result that human being will never imagine. I won't mention once again a case that it comes from the literature. There is a process to generate circuits. There are software which is designed to create circuits for computer and so on. These software are not artificial intelligence, but a few years ago it was generate an experiment, use the real artificial intelligence neural network to create a circuit. The result was crazy, because the circuit generated by artificial intelligence has no switcher, which it means something which is unusual and it never appeared in the history of the circuits. In this case, in order to be even more clear, that the circuit generated by artificial intelligence has no open-close switcher inside the board. Apparently, it is a mistake, the experiment was wrong. But finally, the engineer analyzed that circuit and it worked perfectly, because that circuit was based on wireless interaction, magnetic influence inside the context of the rest of the room. So somehow the circuit was generated to use the Wi-Fi interaction inside the room as a switcher. So the circuit itself don't need any switcher. This is the future. This is the possibilities in the good and the bad. It could be a very good result or could be a danger, because in the case of artificial intelligence, no human can imagine the result. That is the challenge, that is the risk. The future is open. This is the end of this cycle of my course concerning artificial intelligence and architecture and urban planning. Thank you very much to listen my class, and I want to introduce the final bibliography. In the future, we will have other classes concerning architecture and urban planning in the age of artificial intelligence. But for now, that's all, folks. Thank you very much.